Hey, okay, so in the last video we were talking about why is it important to draw a representative sample. Now, we were discussing an example of a box of apples which contained 100 apples and which was our population, and we wanted to draw a sample of 5 apples from those 100 apples from that box, and that box is our population. So in effect, we wanted what would we want? I mean, in layman terms, what would we want our apples to be like? Say on the attribute of the color or the polish of the apples, we would want them to be representative or very similar to the original or the source, which is the population, and which is actually the box. I mean, uh, for us, the sample of 5 apples is the sample with respect to the population of the apples inside the box, because that is our population. But in other ways, or in other contexts, the whole box of apples could be a sample of apples drawn from maybe a particular city or a particular location, all the produce of apples. So it depends upon the context, but then yes, we can draw a sample from a sample and a subsample from a sample. So that's a different topic. But then what the most important point is, what would you want your sample to be like, or what would anybody want their sample to be like? It is supposed to be alike, similar, and in many ways, especially in terms of the attribute that is being measured, it should be similar to the population from which it is drawn. So now, um, uh, another important point is, a sample that is drawn from a population. It is supposed to be not only similar, uh, but it has to, when it is drawn, it has to agree to a basic premise, or a basic assumption that it is not drawn by chance. So we bring chance into this whole concept, because if something happens by chance, we cannot be sure of it, right? If we draw a sample of apples from the box, uh, you know, just by chance, I mean, the as in the attribute of, say, the color or the polish of the apples, you know, is the attribute we're measuring. Um, and we say that, okay, we have some apples. I mean, we are not sure, just in case, let's consider this scenario. So we're not sure that the apples have actually been drawn from that population, I mean from that box. And but we do have, all we know is that we have 5 apples. We want to make sure that it's from that particular box, in that the color and polish of those apples should be similar to all the apples inside the box. Is there a way to ensure it? Yes, there are ways in statistics to ensure, or solve these kind of problems. Uh, of course, and in different contexts and different at different levels. But this is the basic. I mean, this is a representative problem, and um, and if we want to be sure that the sample has been actually drawn from that box, we want to make sure that it is not drawn by chance. The attribute we are measuring, uh, mm, for those apples, or uh, for any sample of, drawn from any population for that matter, has to be alike in terms of those attributes, uh, and for that it has to agree to or comply with a very basic rule, and the rule is that it should not be drawn by chance. So let's move ahead. Okay. Now, in order to ensure that the property of the attributes measured, or the relationship between the two attributes measured, is not due to chance, we need to ensure that the sample is representative. Okay, so now this is a very important assertion, a very important statement that has been made here. So, and let's have another look at it. In order to ensure that the property of the attributes measured, or the relationship between two attributes measured, is not due to chance, we need to ensure that the sample is representative. So I think we have pretty much discussed it in terms of the apple and the the sample drawn from the apple box, and the five apples problem that we just discussed. It is very much in agreement with what we have discussed. In that case, uh, we wanted to ensure that the property of the apples, that is the polish and the color of the apples, which is being measured, or maybe the relationship between the two attributes, maybe the color and the polish. Maybe suppose color is one variable, and uh, that is being measured, and the polish, or maybe the size, or anything that is being measured is not just due to chance. So maybe if you want to determine that, okay, this particular the species, or or the type of apple has should be having a particular color, maybe a maroonish hue, and the polish, uh, I mean the polish, or maybe the size of the apple. Let's take the size. Okay, forget polish. So let's take the size of the apple, and maybe the color of the apple. Right? They are related. Now, somehow we know that the color of the apple and the size of the apple are related, and these are two variables, and we are measuring the relationship between these two attributes, or the variables of the apples drawn from the population of apples inside the box. So we would want to ensure that the sample is representative, in order to ensure that the sample that we are observing is not just by chance, or the traits that are being measured, or the relationship that is being measured, is not just by chance. You know, so even if all the apples in the sample are from the box, uh, it does not ensure that it is a representative sample. So sampling is in itself is a big topic. Of course, we'll discuss it as we go. In one of the future lectures. Yes, but then as of now, it is important to know that it is important to ensure that the sample is representative, in order to ensure that it is not drawn by chance, and vice versa, right? Okay, so moving ahead, uh, it says the attributes are measured through quantitative information about it, called data. You know, a set of values of data, as we already discussed, is called a variable. We already discussed what data represents, and what a variable is. Now, uh, it is important to consider that the attribute, for example, in the Apple example, the the size, suppose the size and the color of the apples are the two variables, and they are being measured, and we have to have quantitative information about it, and in terms of the attributes. The attributes, why? Because the attributes are likely to vary. There are 100 apples, and you can imagine that the attributes, size and the color of those 100 apples is likely to vary. Yeah. So we are, of course, obviously, we are supposed to get 100 values, if we consider the population, or maybe if we consider the sample, we'll get at least five values of size and five values of color on this particular data set or sample set of apples. So a set of values of data is called a variable. Now it's very important to consider that uh, since the values of the variables or the attributes of the apples are subject to change or variation with each particular unit of that population or the sample, that is why it is important to draw a representative sample. It is due to that this variation. We are trying to explain and contain the variation in the sample, so that it is more representative of the population from which it has been drawn, and that is why it is important to consider that everything is being measured in terms of variables, and so we are trying to ensure that the sample is representative. Okay. Now in statistics, we measure population attributes or the relationships between the attributes, or in other words, the effect of one attribute on the other, which is based on the sample attributes. Okay. So it is now, we are coming at a very fundamental juncture, or this juncture we are considering very important aspect of our lecture, our discussion. Now, it is important to note that in statistics, what do we measure, and uh, what 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 exactly represents the population attributes that we are measuring, right? So we say here that we measure population attributes or the relationships between attributes and the effect of one attribute on the other based on the sample attributes or variables, right? So what exactly do we do in statistics? What is the purpose? Let's go back to the purpose of statistics. So the purpose of statistics we just discussed was to ensure that we measure the attributes of population based on the attributes of the sample, right? And that is why we wanted the sample to be alike and representative of the population, right? Okay. Now, in this context, the variables, uh, whether they're based on the sample population, or they exhibit certain quantifiable properties, as in the case of the apple, they represent the attributes of the population itself, right? Okay. Now these quantifiable properties, uh, you know, or the attributes that are being measured and are called variables, uh, in terms of variables, right? And through variables, um, uh, you know, these quantifiable properties. Now, we should be careful. We should not confuse variables with statistics, or quantifiable properties. But the quantifiable properties, which are being measured in terms of the variables or the attributes of the sample or population units, uh, are called statistics. Okay. So statistics is not just a